Yeah.
Okay, give me a second. Connected. Perfect. We're live. Hello, everyone. I'm Dr Dounas, and I'm very happy today to host a very excellent researcher and collaborator, Dr. Jens Hunhevicz, who is going to present to us a chapter from a book. Let me set this up as well. The promise of blockchain for the construction industry, governance lens, and this is the first chapter out of the book, Blockchain for Construction, that came out last year in September. And we're hosting this series of talks in Archidao to try and explain to people why the book is here and all of the excellent work the researchers and authors have done. Let me try and stop sharing here. Sorry. I'll try and introduce Jens as well. So Jens is initially started as a civil engineer in ETH Zurich, and then did his. You did your PhD directly, right? Or did you do a master's first?
I did a master's in civil engineering.
So he did a master's in civil engineering as well, and then he did his PhD in the chair of innovative and
industrial construction. Yeah.
Perfect, with Professor Daniel Hall, and he's one of the first people that looked into blockchain for construction, and that's how we met essentially and started talking about it and then worked together as well. So we're very happy to have you here, and let me try and set up the sharing. You should be ready then to share, and Jens is going to present his chapter, and then we're going to have a discussion on the content.
Okay, let me try to share. Is this, do you see my presentation?
Yes.
Without the presentation mode?
Without the presentation mode, yes. It's
good. All right. So yeah, thanks for the introduction, Theo. Thanks for hosting me. And I'll try my best to briefly introduce you what the chapter is all about. I'm currently a postdoc at a chair of at the CA lab. Actually, it's still the old lab there at ETH Zurich, and the Urban Energy System lab at INPO. All right, and as Theo already said, that's the chapter we will talk about today. I wrote it together with Dr Dounas and also my professor Daniel Hall. So the motivation to write the chapter was that we noticed that there was more and more research on blockchain for construction, but they often applied the technology to existing processes. And over the years we were working on the technology, we noticed that there is also a more long-term potential, which for new economic coordination in the construction industry. And we tried to put together a very high-level summary of these observations we made. And with that, we hope to inspire or more research in these directions. So why do we target the construction industry? Basically, because we research on this topic. It's one of the biggest industries in the world, and it suffers from complexity and trust issues since many years. And construction has been described as a complex system. And if you look at if you're not so familiar with construction, then you can look at this picture and you can see the many interacting and moving parts of such a construction site. So these projects go on for a very long time. They have a lot of different specialized firms or trades that need to work together. They're dependent on weather, they're dependent on each other. Then you see trucks arriving, they're depending on traffic and supply chains, and it's actually very, very hard to coordinate a big construction project. There is also many studies that suggest that predominant forms of organization in the construction industry fail often to deliver this trusted coordination. And we will talk a bit more about that later, why this is the case. There is often a misalignment between what would be needed from a theory perspective to manage a complex system and what's actually in place as a governance or management structure in construction. Because of all these trust issues, it's not so surprising that some researchers started looking into this new hype technology called the trust machine. That's the cover from The Economist in 2015. So it was about 2017 when the earliest papers emerged on that look at blockchain for construction. And that's also the time I started my research on blockchain in construction. So I'm working on that for some years now, but you already see that it's still quite a new technology. There's still a lot ongoing. So just keep that in mind when we talk about all these things. We are all trying to figure that out at the moment, what this technology actually can do for us. So I suggest that there is actually new forms of economic coordination possible for the construction industry. And I want to briefly make a short detour to why this is actually not such a new idea and that it's already been done before through other means. So in a general, like in a traditional form, the project is organized with a lot of firms that need to coordinate together, and you have mostly a coordinator, sometimes a general contractor, sometimes it's set up a bit different, but in general, you have a coordinator trying to coordinate the project. This is a more hierarchical approach, and basically you can see the budget and schedule of key resources of this project. And of course, as a rational acting firm, you're incentivized to use as many resources as possible because you're interested to make a profit. This hurts the overall project because the general contractor basically, or the coordinator, needs to align everyone so to the most, like, to deliver a successful project. So this behavior hurts the overall project. It's a very simplified view, but that's the high level, and I think it's not such a bad high level view. There is some alignment between what's happening in these projects and common pool resource theory, where you have the tragedy of the commons. So basically you have kind of a lake where everyone goes fishing, or a pasture, and everyone puts their cows and they graze. So what can happen is that the resource can deplete because everyone is only interested in exploiting as many resources as possible for their own benefit instead of coordinating with each other to kind of sustain the resource. So Elinor Ostrom won the Nobel Prize for suggesting that bottom-up coordination, like through some principles she explored through case study research, that bottom-up coordination is actually is better suited in these cases to avoid this tragedy of the commons. And then there is like new forms of project delivery emerging, like integrated project delivery, that try to establish new economic systems more in line with, for example, common pool resource theory. That's also been explored in a paper you see here by my professor, Daniel Hall. So basically these new project delivery modes, they also start to change economic coordination to better manage these projects in just a slightly different way. So what they do is they pool together these resources. Instead, they have a central coordinator who assigns these resources or tries to assign them to different stakeholders. They're all together in one pool. They need to coordinate amongst each other who will use how much of these resources or how many of these resources. And then if the overall project in the end is a success, they share the benefit among all actors or the loss. So it's a shared risk reward contract, basically. And these bottom-up coordination mechanisms, they resemble some of the Ostrom principles. So there is already some new form suggesting bottom-up or more decentralized coordination for construction project as a better means of coordination. So there is this early evidence that this is actually a good thing. This is also, we touch about it later, also in line with complexity science, but also suggests more decentralized structures are better suited for complex system management. And the next very interesting observation that I want to show you is that blockchain can also be seen as a CPR scenario. So a blockchain is can be similar to free and open source software, where everyone is incentivized to free write, but someone needs to maintain the resource. Wikipedia is one example of such an open source project. There's a lot of people just free write, they use the resource, but very few people actually contribute to the resource. And in a similar way, blockchains, everyone wants to use the blockchain or benefit from the cryptocurrency, for example, but very few people actually want to contribute by running software, by running these mining rigs, for example, you see here. And actually, this is a collective action problem that blockchains need to come up. And the solution they found is a new form of economic coordination through incentives, like cryptoeconomic incentives. So it creates these decentralized incentive mechanism, governance structures, so that people better coordinate to avoid this tragedy of the blockchain, basically. So it's actually very interesting that blockchain, because of its setup, is a new form of economic or facilitator for new types of economic coordination. And with that, it's an institutional innovation with potential to disrupt and substitute economic coordination. This has been identified by others as well, for example, in this paper by Davidson, De Filippi, and Potts. So this means it's actually very important to understand what the technology actually does to understand what forms of economic coordination are actually feasible with blockchain. And a lot of people just skip this step and they say, well, we use blockchain to create more trust, but it's actually very important to understand what's actually happening on a technical level. And I briefly want to take the time here to discuss that also in this presentation. It's also in the book chapter, a very high level overview, how blockchain establishes these new economic forms of coordination. So on the one hand, we have the technology stack. So blockchain is based on the internet as a information protocol, exchange protocol, to distribute information across all computers or facilitate information exchange. Then you have the DLT layer with like 3 technical components that we will quickly look at, and then the application layer. On the right hand, you have what is called the fundamental properties of a blockchain. So if a blockchain is set up as it should, basically, then you have these properties facilitated by the technology, and you often hear them. So you hear that transactions are not repeated. You can check whether transactions are integer or valid. It's very transparent. You can see what's happening. Everyone can join the network, so it's not exclusive, and it's not changeable. So once it's written to the blockchain, you cannot change it. So that's what you always hear, but how this is actually achieved, often people don't really understand, or just, yeah, it takes a bit of digging to understand how this all comes together. And it's a simplified view that I show you here. It's of course, I don't have time to go into all the details. So it depends also a bit on the blockchain that you look at, but in essence, that's how it will work in most blockchains. So you have the ledger. It's called the ledger, which is basically the database of a blockchain, which stores transactions, and it does that in a very unique way. So basically, while we transact on the network, for example, Theo and me, between each other, we pay each other, we interact with smart contracts maybe, and these transactions are propagated through the network. They're clustered, they're put into a block, and then when more transactions arrive, they're again clustered and put in the next block, and so on. So there is a sequential chain of blocks forming this chain that's stored on a computer. So that's why it's called a blockchain. And these blocks, they're sealed together with cryptography, and and this allows them that they're not there is no reputation of transactions. So basically, this is done through hashing. A hash is a one-way mathematical function you apply to any string or data. For example, blockchain hashed with the SHA-256 algorithm gives the string. If you just slightly change an input, it completely changes the string. So there is just slight input variation completely change this basically signature. It's like an ID of the string. And what's happening now in the blockchain is that the hash of the previous block is always stored in the next block. And if you change just slightly transactions in one block, it changes this block hash, and you would immediately notice that they don't match anymore. So this means you can also check whether transactions are valid. So because it's sequential, you know when which transactions happen, so you can check whether they happened before. So it's non-repetition. And because of the hashing, you know when someone tries to change some parts of the blockchain, you immediately notice this because the hashes don't match anymore. You wouldn't trust this if it's just on my computer, so it's very important to distribute that in a network, right? So you have a network of ledgers that makes it possible to keep each other in check. So I can check whether Theo's ledger is actually the same as mine. So it's very transparent. And all these things, for now, they just ensure that we can transact and we can trust the ledger as it is. So it's all what happened in the past we can trust, right? But it doesn't solve how you can add new transactions. And now the interesting part comes. Each blockchain has a governance mechanism to ensure that new transactions are written as they should to the network. So the easiest way would be to just assign a leader, and you say you coordinate transactions. It says, yeah, we want to write these and these transactions, but then you don't have equal rights anymore. Not everyone can write the blockchain anymore. And if this one turns bad and he tries to double spend or attack the network, you lose the whole features of blockchain. So there is no equal right, there is no immutability. So one better version that also is used by some blockchains nowadays, more private blockchains, is like a random selection of registered nodes to add transactions. So you have multiple kings and they get randomly selected to add new transaction. So it's a bit better in terms of equal rights. At least don't know only one, you have multiple, and you have some sort of immutability because they would actually, it's harder to coordinate to attack the network. But you need to know and trust the participants. You need to know who runs the network. So this is a limitation when you want to scale it to like very large systems, because it's still a coordination issue, right? So the main innovation was when Bitcoin introduced proof of work as the first consensus algorithms. And there is more nowadays, but this was the first that solved this coordination issue, so that you don't need to know who is participating in the network, and still can trust that the transactions are written as they should, so they don't double spend, or they're not malicious in any way. So they do this by introducing this cryptoeconomic mechanism. So basically, they can earn rewards by behaving honestly, and need to participate in a very expensive lottery to add transactions. And if they get caught cheating, they don't earn the rewards and spend all this money. So they're incentivized to keep this mechanism working. And often they hold also the currency. So they don't want to attack the network that actually they have stored their value in. So there is a lot of different incentive mechanisms. But it's actually very interesting that it's a human incentive mechanism that secures these technical systems, right? Which is actually the key point, right? That with these new technologies, you can build incentive systems for humans, right? By using economic incentives, so basically money, most of the case. So just very briefly, there is of course a lot of like thousands of versions how you could implement all these different parts of the technology stack, and it's not part of this presentation to go into detail. But there is if everything is as it should, you call it a public permissionless blockchain, and you have all these properties on the right, and then you can tweak some things, and you sometimes lose a bit of these fundamental properties. So you have a bit less trust in the technology, and you need more trust in the users. It's always a trade-off, but of course, mostly performance increases if you do this. So there is also good reasons why you should do this sometimes if you don't need that much trust in the technology. Anyways, so finally, there is this application layer where you can encode logic to interact with these transactions. And here it becomes very interesting, because we then can use all these cryptoeconomic mechanisms and transactions and features of the blockchain to create our own economic system. And these smart contracts can encode workflows, but they can also encode tokens. So it's these value containers that you can send around in the network, either as money, for example, Tether is a stablecoin that tries to be money, or you can have unique tokens like NFTs that, for example, represent a piece of artwork, but it could also represent something else in a construction-related context. So the high-level overview is this: you use blockchain as this base layer for trusted digital processes. You have the transparency, you have immutable transactions, you can scale the network to a lot of people because it's peer-to-peer, and you have this logic. And then you can use these tokens and smart contracts to create new forms of incentive mechanisms to incentivize certain behavior in the system. Okay, so in the book, we have then 3 lenses where we describe how this potential of blockchain, or how this aligns with construction. So the first lens is related to complexity. So it's that bottom-up processes to manage complexity are in theory better than hierarchical approaches. There are a lot of examples in nature. For example, bees, they have decentralized coordination mechanism to manage themselves, but you also have in system control sometimes more decentralized control approaches, so like for traffic control, for supply chain logistics, or for like wind turbine optimization, they often use decentralized control approaches because these complex systems are very, very hard to control in a hierarchical approach. And construction is a complex system, right? And we already have some early evidence with IPD as a more decentralized management approach that these systems tend to work better than traditional project delivery models. So what if we could create even more decentralized systems with this new technology, with these new coordination mechanisms? In theory, this aligns with the complexity science that such systems should be more efficient to manage construction projects. Of course, we haven't implemented them, so we don't know yet, but that's the theoretical idea behind. Then we have something called, because in the industry is a complex system, it evolved over time into a certain system that we call, that is characterized by fragmentation. So usually you see these patterns. So you have a construction project is vertically fragmented. So you have a design, construction, operation phase, and in each phase you have new actors. And what often happens is that risk gets pushed down the supply chain, so that some actors arrive, they do something, and then they leave. And everything that then the next one has to correct all the mistakes from the previous one, and so on and so on. And this just goes on. So basically risk gets often pushed down the supply chain. Then you have horizontal fragmentation because you have a lot of different trades that are necessary. You need a lot of very specific knowledge to complete the construction project, and they need to coordinate between each other in each phase. And then you have longitudinal fragmentation, which means basically because it's a project-based industry, every time we start from scratch. So you have a new construction project with new actors, with a new project management structure. So that every time you need to coordinate again, and you lose a lot of knowledge. So there is a possibility to create integration incentives to better align these construction projects across phases, across trades, or across projects. So it's a very, very obvious case how you could use incentives for construction projects. And like these risk reward boundaries in IPD do this already to some extent for a project. So it's one way you could also use it. And then there is a very interesting observation that construction itself is often a very decentralized industry, or construction projects on its own are also very decentralized. There are some studies like this one from Book. There is also others from Konrad Grase, for example, that looked at one construction project here in Switzerland, that these are very decentralized. So if you compare now construction, for example, to manufacturing, you see a lot more blue, and blue means, now I need to be careful. Blue means external connections. So you have way more external connections, so way more coordination is needed in a construction project compared to other industries where you have way more red internal connections. So it's actually alignment between the decentralized nature of how blockchain works. This is a decentralized network to facilitate economic coordination, and also construction is a decentralized network that needs to facilitate coordination. So these mechanisms should also, regarding this, be very well suited for an industry like construction. So these are the three lenses. They're somewhat related, somewhat different, but they all point to the direction that blockchains actually could be a very well suited technology for an industry like construction. So the question is then, what does this mean compared to other approaches we see nowadays? So we came up with this figure trying to show people on a very high level what we think is actually the potential. So if you imagine that you have on the left side construction projects that are more hierarchical control, more centralized, and on the other side you have the construction as a decentralized network, then what we have more at the moment is a misalignment of these of the industry structure with the governance mechanisms. So at the moment we often have a decentralized project setting. We saw that before in the slide, but often hierarchical top-down approaches to manage them. And in theory, it should be bottom-up approaches for decentralized systems. So what blockchain could do is shift this to more decentralized governance mechanism. But what we currently see is often the opposite. We see at the moment a lot of approaches that try to shift the industry structure to the left. So they try to reduce complexities by vertical integration, for example, of the supply chain, like streamlining the supply chain, buildings as a product. So they try to reduce complexity to make the industry structure better suited for these top-down or hierarchical central managed approaches. It's one way to go. It could be successful. I mean, in theory, it can be successful. In practice, it sometimes proves to be difficult, but the future there is a lot of efforts now in this direction. So we will see how this turns out. We just suggest that actually with this technology we have, we could keep the decentralized structure of projects and try to shift the governance structures towards bottom-up approaches. So they also align and in theory be more efficient. So it's an alternative vision for what often people say construction 4.0, so the next generation of construction projects. And to finish up, I want to show you the last part of the book where we think a bit about how would you go about implementation? What are the different steps? And we differentiated between 3 levels of adoption that made sense for us by the time of writing this book, and I still think it's a helpful lens to view this. So what we often see nowadays is that blockchain is used as assurance layer for existing processes. People want to increase trust by timestamping transaction, by tracking the supply chain. Sometimes they also suggest to use payments as a more transparent means for project finances. For me, this is all using blockchain for the system we have nowadays. And because it has so many trust issues, it's already a good idea. I'm not saying that this is any bad. I actually think it's very good that we see all these efforts trying to apply blockchain to the systems we have nowadays. It also helps with technology adoption, people getting used to this new technology. It's a very good first step. But the observation is that most research and implementations are on that level. And what we suggest is that the more long-term potential of blockchain lies in the other 2. So as a next step, you could start to embrace more decentralized incentive mechanisms and markets. The advantage is you can still use similar actors as you have nowadays. But for example, you can try to leverage some of these coordination mechanisms to create new business models or new forms of economic coordination. One example that we were looking into was using blockchain for the energy performance gap. So there is an observation that the difference between design buildings, how much energy they should consume and how much they actually consume is actually pretty big. So this study suggested up to 250% higher for the projects they were looking into, which is a pretty big difference. And the reason is often exactly this fragmentation, right? So the people that actually design this system, they're not involved anymore when they get constructed, the system gets constructed or even operated, right? So they try to design it, but then things change. It's not even more, maybe they don't even design it wrong, but then things change. They gets implemented in a slightly different way, and in the end, it gets operated in another way as it was not intended at the first place. So there is always this gap between all these actors, right? And what's actually missing is to bridge the operation phase with the design and the construction phase. And there is like a traditional vehicle, it's called performance-based contracting, to trying to bridge this gap, which is an incentive mechanism. So what you want to do is you want to reward the designer and construction parties based on the performance in the operations phase. So you set up this performance-based contract. That means, yeah, if the performance in the end is in the range of this and this, then you get an additional reward, for example. But it's actually very often these performance-based contracts don't get implemented in construction, even though it's a pretty good idea, because it's so long-term. It's very hard to know the actors that will be later involved. So it's actually very hard to set this up. So what if you could use a smart contract that just encodes the terms in a logic way, connects this to sensors in a predictive way, how you will measure this performance, and later actors, they just need to sign up. So you don't need to know them at the moment, but you can still set up these contracts in a way that they could work. So you can start to use and then set automatic payments and rewards based on blockchain, right? If the performance gets met. So it's actually a very straightforward use case how you could use such new economic coordination mechanisms for a business case that already exists. And I'm sure there will be way more options how you could implement such new incentive structure, trying to bridge these fragmentation gaps as an integration approach. Also decentralized markets to trade products or tender projects. All these things, they could bring a lot of value, but they're not so far away from completely new coordination. And finally, you could really go a long way and try to completely implement new governance structures with decentralized decision-making and ownership, where you don't even need to know the actors anymore that maybe contribute to a project. And you just have coordination mechanism in place that make sure people are aligned towards the outcome. This sounds very futuristic, but it's actually, I think, a very exciting vision. Whether it's possible or not, the future will show. But there is this idea of these trusted processes for autonomous things. So that because blockchain is doesn't need to know who owns the addresses, they could also be owned by a machine or an infrastructure or a building. And then these buildings could self-sustain themselves, basically, similar as nowadays we interact with nature. So they just are and provide their services, and we humans interact with them, of course, delivering some of these services, for example, building them or maintaining them. And we explored this with No One's On, a very simple prototype, which is a self-owning house on the blockchain. So it owns its own funds. It has a revenue mechanism. When you go in, you pay the house. And we also working on ways to figure out how it actually can spend the money. Then again, not just getting richer and richer for maintenance and operation mechanisms. Could also construct itself, for example. So basically, early prototyping is possible. It's not just some idea, it's actually implementable, but of course it has a lot of challenges. The technology is very early state, and we have a lot of technical difficulties. But as a key takeaway, the book is actually, the book chapter proposes this new high-level overview on the promise of blockchain based on some observed alignment between economic coordination of construction and blockchain. And we suggest that it can be used for this new governance technology for this or for a new vision of construction 4.0. And of course, we are only at the beginning of this journey. It's basically, we wrote this book chapter during the time of my PhD. So there is a lot of opportunity for more research in a lot of ways. And I think it's, yeah, and we hope it's helpful to people that were trying to understand what blockchain can do to identify research areas. So all these things are also in my thesis if you're interested. and to learn more about different aspects, or we can discuss now the questions. Thank you.
Perfect. Thank you so much. Thank you. It's always a pleasure to hear you explain blockchain for the construction industry, because you break it down into such simple levels that is, to the point every time. I think, I have always lots of questions, but I'll start with the first one, which is, what piqued your interest to look into this, right? How did you start to? We're now kind of, you say we're at the beginning of the journey, right? But actually, your beginning is, I don't know, 3 or 4 years earlier, right? Thinking of you run into blockchain, and how do you think about, is this a good idea or not? Because it is a leap of faith, right? I had similar kind of thinking when I looked into the technology.
I think it was just a long journey. So basically, when I started in 2017, it was really on this first level. So I thought, okay, you can create these trusted mechanisms. For example, you can timestamp contracts. You can make sure that you can prove they existed as they were at a certain point in time. And only these little things, or you can track the supply chain, only these little things actually could make a difference, right?
Yep.
So I do think that the research we see now for existing economic process is actually very valid, right? And it's also how I started. But the more I learned about how the technology works, how it facilitates the economic coordination within the blockchain system, and I had the luck to be in a chair where my professor Daniel Hall was working a lot on these new collaborative project delivery models like ITD. I started to see more connections between these new construction project delivery models and the economic coordination mechanisms in blockchain. So basically, I started to see the potential power of these incentive mechanisms, right? And that's something I didn't at the beginning. It's just basically by doing our research, we started to see more and more of these connections, right? And I haven't really, the big question is, how would such a decentralized project delivery model actually work? And what are the mechanisms that need to be implemented? And I also don't know. That's actually the big next question. The book chapter doesn't really give an answer for that. It just points in this direction. It outlines the many observations that I made during this journey, where I see similarities between how blockchain economic coordination works and how the industry could work, or works with some of the more decentralized approaches.
Well, you're going to find it funny, because part of what we're trying to do in ArchiDAO is kind of try to set up, at least for the architecture part of the AEC industry, some of these processes, right? And I won't reveal yet what we're doing in detail, but when we started looking into what we're building now, we started with timestamping, because you go, okay, how do you build it, right? Can you actually deliver a full set of smart contracts and suddenly, release them to the world and people start using them, right? Probably not, because you need to coordinate on the human level of, how they will start doing it. So you start first by trying to also convince people that this is doable by starting with the simple processes first. So potentially the step is, your classic diagram of, we start with less decentralization and, really simple applications. And as this gains the trust of people that, this is working, and you don't get any kind of rug pulls or all of the other kind of bad reputation that certainly certain cryptocurrencies have, and maintain the technology as well. I think people will start seeing the benefits, right? And what I find always interesting is this idea of autonomous system, right? Because when I started training as an architect, you always had this idea that you will own your software, or you will have a license and then you use this to actually design and then maybe construct something. Whereas we're now going to the level where the software just is there, or the system is there, and you go and try to use it instead of having to kind of rent it or buy it or all of that.
Yes, I think it depends a bit on the software that you use. I think the software that will ideally is just there in the end is exactly this software that facilitates the coordination mechanisms. For example, decentralized decision making, decentralized dispute resolution, all these things. And then there might be more specialized software that people use to design. Maybe it's also open source, but I think this has then a bit less to do with the system in itself. It's more with the value creation. Then I think it can still happen. For example, an architect can still design, right? The funny thing is actually that when you talk about autonomous systems, is that there is this like whole emergence of generative design and AI creating all these designs. And the interesting part is more than that they could also participate in these design competitions. And I really liked your research, right? Where you actually showed that in some way, right? That I mean, this autonomous system could also participate in this economic coordination in the end. And I think that is actually quite an exciting or futuristic idea, right?
I think that's where it gets interesting, and we see it now more with these approachable, AI systems that now have become available to everyday citizens, essentially, right, out of the lab. And they're not perfect, obviously, right? There's always shortcomings to the systems, but you also get another level of tension here in discussing, for example, all of these AI systems that have been trained with open source materials. You get artists, for example, or designers saying, well, you're stealing my copyright and I don't have any control over the AI. And I think that's the other kind of aspect where blockchain might come into the levels with these autonomous generative systems, where you might need it for governance, essentially, right? And this is where it will be it's true valuable application rather than just as a storage system.
Yeah, I agree, but I do think it's less dystopian than it sounds. I think actually these decentralized systems, I mean, when you talk about autonomous systems, people always think, oh no, then I don't have a job anymore. But I actually think these decentralized systems can actually help smaller companies or single actors in this, like in terms of value creation, because they're more independent now, right? And the project because of this bottom-up coordination, you don't need a huge company with a lot of knowledge. You can have single contributions, maybe from smaller actors that get coordinated towards the bigger system. So it doesn't need to be necessarily bad for the end user in a way, or the people having the value creation. That's not just something I wanted to mention, but of course, it needs to be seen how these systems are implemented in the end. And from that perspective, we can learn a lot from the blockchain space in general, right? I mean, the cool thing about this open source technology is there's so many experiments out there, just not in construction. You have all these DAOs, these decentralized autonomous organizations. And basically what they try to do is to establish decentralized coordination mechanisms around a shared pool of value, mostly a pool of funds, right? Money that they want to do something with it. And then they have these anonymous contributors from all over the world trying to coordinate towards peer production or value creation. And I think it's exactly where we can learn, or will be able to learn a lot from, right? And try to apply these systems maybe to some aspect also in construction. But we are at the very beginning. So now all these experiments are happening, and basically what we need to do is we need to observe and see whether they work or not, and what works better, what works less, and then try to adapt to one or the other approach, maybe also to construction. I think that's actually maybe how we could do it, because otherwise creating this bottom-up coordination process is very hard, right? You could,
Yep.
It's not something that can, or it's probably something that it's hard to top-down implement. It's hard to just design it and then it just works. It will also need to grow through experiments. So saying, yeah, these coordination mechanisms, they work better than others. Maybe we could help with simulations, or so we could try to identify how they would work. So have a probability space, but yeah.
I've been looking a little bit onto simulations for token engineering with CAD, for example. And I mean, but then it's a particular type of market that they're trying to create, you know. I think, you know, we've seen it in Archidao as well, right? We started like a group of people saying, okay, this is a cool idea, so why don't we, try and do something with it? And it, I think the most difficult part in this bottom-up making of an organization is aligning interests, being really patient with one another. It's on a human level, what is going on is really interesting because they have so many discussions and so many people coming in and trying to contribute in a sense. And it also fits on what you want to do. And I think your point on the industry, on not seeing this as a dystopia, but rather as a good thing is absolutely spot on, because the construction industry has a lot of SMEs, has a lot of small companies, right, that need to come and work together. And it's always difficult to coordinate them, right? Because you change the place and then you need to work with someone else, or forward in time, an SME has moved on, right? So I think it's more this idea of autonomous systems, not on the, as you said, the robot is going to take over our jobs, but rather the robots are going to create more opportunities for us, or automation on a simple kind of level.
Yeah, I think it's important to mention that I don't think these decentralized systems are just superior, for example, to centralized approaches. Like, I think vertical integration has shown in many other industries that it's actually very, very efficient. But decentralization ensures more robustness, basically because it's flexible and depends on a lot of small actors. The overall system is actually very robust. And I think it's actually a reason why the industry is as it is nowadays. It is a decentralized system most of the time, because there is so much uncertainty also on a higher economic level, right? You have economic downturns, and sometimes you have inflation, sometimes people cannot afford houses anymore. And then suddenly if you have these big vertical integrated companies or firms, then they go bankrupt in these periods of time because they have this risk, right? And some smaller firms might also go bankrupt, but a lot of them just adapt and survive, and then they do work wherever it's needed. Yep. And then when the economy, for example, picks up again, they reform and start delivering value again, right? And I think it's a very flexible system, and somehow this flexibility also seems needed, right? And maybe someone will figure out how to integrate everything without this huge risk, right? But so far this has not really happened yet, right?
Right. I think it's absolutely very difficult, but I think it introduces also a question. I don't know if you've read the book about anti-fragility by Nicholas Taleb, where he kind of makes the case between robust systems but also anti-fragile systems, so systems that become stronger the more stock they have. And one of the kind of ideas that I've been thinking about is trying to look at the construction industry and the AC industry as an anti-fragile system, where kind of blockchain might help with those kind of ideas. But maybe for our next discussion. Thank you so much for the presentation and the robust discussion, and we'll talk again soon. everybody watching this. Jens had his contact on his presentation. You want to say again the last slide if anybody wants to contact you?
No, it's just Google my name and you'll find me. It's a very unique name.
Totally easy and totally straightforward. Jens, thank you again for this, and we'll talk soon.
Thank you for the invitation.